Properties, stress and strain. The external loads and sigma is equal to F by A. This in the video will be explore the concept of the using simple external load var. Here we have a solid metal and that is loaded to the equal what opposite force. We refer to this axial loading because of the load, the same axis. The two forces are the pulling the var causing in the stretch. Internal force will develop within the var to resist these apply. We can absorb this normal metal force making an imaginary cut through the var. Internal force. I choose to remove of the right side of the var what I could have removed the left side instead. And for any imaginary and cut the like one internal force develop in the such a way that equilibrium will be maintained. In this case, the effect of the internal force acting the force across the section operated cut equal to the effect of the apply external force. Internal effect of the internal force is equal to is represented the internal force and force separate force here the what I called them as one even the 20 forces. In reality, internal force are distributed over the entire surface of the cross sections. For this section, it does not make such sense to talk about specific internal force. Strain is the better to the solve about stress. Stress is a quantity that describes the distribution of internal force within a body. It makes easy to discuss the internal state that develop within externally applied load. Stress, force y area, n y m square force y area IB upon n square. SI unit and US subunit. Newton per meter square also called PA. In this case of our axially loaded var it directionally and type of screen is called normal stress. We can calculate normal stress in our var apply for F divided by normal stress A. Mu F divided by A normal stress is denoted by the Greek letter sigma. 1% within the able to the particular stress is important because it allows when an object will fall. Let's say our wall from the middle steel which has strength of 20-50 ampere. The wall fell if the withstand within the exit strength of the material. It over the wall diameter of 20 meter. For example, we can calculate that it will mu fail the occur when mu F is equal to mu Fa fail normal stress. Normal state can be either tensile or compressive. In this case, the stress is tensile because the force or stretches the var. If the force was trying to shorten the var will have compressive. Compressive stress and tensile stress, two types. Positive and second is negative. In this case, our var is reasonable to assume that states are distributed uniformly across the sections and along the length of the var. What is very simple scenario? The stress. The stress will be the turn side of the cross sections, compressives and tenses. Strain is a quantity that describes the deformation that occur within the body. Strain is a describes if we fix our var at a tone one apply force to the other side, force will be cause var to deform. Delta L. The normal strain is our var associated with the deformation can be calculated. The change in the length of the delta L divided into the original length.